Hello everyone, welcome to Enviro Pioneers. In this video, we will be discussing about coal, which comes under fossil fuel and is an example of non-renewable energy resources. Non-renewable resources are those resources which do not replenish within a short time to keep up with their consumption. So the meaning of replenish is to replace what has been used up. And as these materials took millions of years to form, they will also require another million of years to replenish. And the example of non-renewable energy resources are the fossil fuels and the nuclear energy. And within the fossil fuel, we have the coal, oil, and the natural gas. And when we talk about fossil fuel, the term fossil, it means a remnant, impression, or trace of an animal or a plant of a past geological age. यानी जो बहुत पहले जो भी animal या plant थे, उनका जो भी remnant है या जो impression है या trace है, उसको हम fossil कहते हैं. And the fuel is the material that can be burned to produce heat or power. And the coal, petroleum, and natural gas, these are called fossil fuels because they are derived from the remaining of prehistoric plant, animals, and the microscopic organisms that lived millions of years ago. So, in the Paleozoic and the Mesozoic era, which was 100 to 500 million years ago, उस टाइम में फ्रेश वाटर स्वैम्प्स एंड shallow seas they covered vast area of the globe and it supported abundant vegetation and the phytoplankton. Because of the anaerobic condition in the lowest layer of these water bodies, there was decrease in the decomposition process by the microorganisms, and as a result, massive quantities of the dead organic matter it accumulated at the bottom, and over millions of years these organic matter were gradually buried under the layer of sediment and was converted because of the pressure and heat to fossil fuel, that is coal, crude oil, and the natural gas. Now coming to coal, coal is a combustible black or brownish black sedimentary rock which is formed as a rock strata and is referred as the coal seams. And it is mostly carbon with variable amount of other elements, mainly hydrogen, sulfur, oxygen, and nitrogen. And this coal is result of plant material that grew in freshwater swamps approximately 300 million years ago. This image, it represents the formation of coal. So here we have the freshwater swamp. So the vegetation either in the form of the phytoplankton or from the nearby area, when they get died, they get deposited at the bottom layer of this water body. And because of the anaerobic condition, the decomposition process got delayed and material got buried under the sediment. So the first stage is the peat, that is the partially decomposed organic matter. And when this material was buried under more and more sediment, it was further compressed to form lignite and then subbituminous coal or bituminous coal and then into the anthracite. Let us consider a scenario where the freshwater swamp was buried under the sediment, and because of the heat and pressure caused by this sediment, the first stage of the coal formation is the peat. And with time, more and more sediment got deposited there, and because of increased heat and pressure, this peat is converted into the lignite. And with passage of more time, further deposition of more and more sediment, because of this, the heat as well as pressure, it got increased, and this lignite was converted into the bituminous coal. And with further deposition of more sediment, this bituminous is converted into the anthracite. So there are four stages in the coal formation process. So the partially decomposed material, it is referred as the peat. When this is subjected to heat and pressure, it is converted into lignite. With increased time, increased heat and increased pressure, it is then converted into bituminous and then anthracite. And you can see the difference in the texture and the color of this coal. So the lignite, it is referred as the brown coal, and the anthracite, it is referred as the black coal. So here again we have the same representation where we can see that this peat, with passage of more time and because of increase in the heat and the pressure, this peat is converted into the lignite and the coal. So here also we can see that when this peat, it is got buried in the further deeper layer, this is converted into lignite, then it is converted into bituminous and the anthracite, and a sub-stage in between lignite and the bituminous is subbituminous. The formation of coal is referred as the coalification, and this term is defined as the process of gradual change in the physical and the chemical properties of coal as the pressure and temperature increase during the geological time. So here we can see that with increase in the burial depth because of the deposition of more and more sediment at the top of it, this swamp, it is first converted into the peat, then lignite, bitumen, and then anthracite. So what are the formation condition? With time, because of the increase in the burial depth, the pressure and temperature on these material, it increases, which cause the metamorphism from the peat to the anthracite, resulting in increase in the carbon content as we move from the lignite to the anthracite, and decrease in the volatile matter. So if we talk about the carbon content, there is 40 to 60% carbon in the lignite coal. In the bituminous coal, we have the 60 to 80% carbon, and then in anthracite, we have the 80 to 90% carbon. So here we have the state-wise coal and the lignite reserve for our country India for the year 2024. So the different shades of black, they represent the different range in the quantity in million tons, and overall quantity is 3,89,421 million tons for our country. And at this particular website, you have this option of shifting from coal to lignite. So as you move this towards the lignite, the data will be displayed for the lignite. So you can visit this particular website which is mentioned here for the niti.gov.in. And in India, this coal is classified into two categories, the Gondwana coal and the tertiary coal. So there is difference in the carbon content and the time at which this particular coal or this material was deposited. So here we can see that this Gondwana coal, it belongs to the Carboniferous period, which is 600 million years to 300 million years back. And 98% of the total coal reserves of India, it belong to the Gondwana period, and it mainly have the bituminous or the anthracite coal, in which the carbon content, it varies from 60 to 90%. And the tertiary coal, it is found in the rocks of the Oligocene period of the tertiary era, and it is about 50 to 60 million years old. So you can see the difference. This one is 600 million years to 300 million years back, while the tertiary coal is 15 to 60 million years old. So this deposition is very recent in comparison to the Gondwana coal, and it mainly contained the lignite coal, which is also referred as the brown coal, and it contributes only 2% of the total coal production of the country. So the data about the Gondwana coal and the tertiary coal, it can be obtained from this particular website for our country. So when you click on this particular website, you will be navigated to this Ministry of Coal, and here we have the coal and lignite resource, and according to National Coal Inventory of 2023, which is published by the Geological Survey of India based on the resources estimated by the government agencies and some of the public or the private entrepreneurs, and a maximum depth up to the 1200 meters. So the total estimated coal reserve of India is 378.21 billion tons as of the 1st April 2023. So you can visit this particular website if you have interest in this particular subject. So here you can see that with continuous exploration effort in 64 coal field, 45 Gondwana and 19 tertiary field. and 15 lignite fields have resulted in substantial augmentation of the geological resources of coal and lignite. So here we have this Gondwana and the tertiary coal field, and in at this particular website you will be finding the information about the coal resources and the lignite resources. Coal varies widely in important physical characteristics like the energy content, carbon percentage, moisture content, presence of the contaminants such as sulfur, and these attributes they determine both the price of the coal and the uses. So these properties are utilized to grade the coal, and the grading is done on different bases. For example, in United States, the calorific value is utilized. So the calorific value of the coal is measured for almost all coal samples, and it is the measure of the heating ability of coal and is required to estimate the amount of coal needed to produce a desired amount of heat. And this calorific value can be measured in the standard English unit, that is the British thermal unit per pound, or in metric units like the kilojoule per kg or the megajoule per kg. So this British thermal unit, it is equivalent to the amount of work needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. And from this English unit, the metric equivalent unit can be calculated using this formula. So here we have the US coal rank system showing the parameters which are used to define rank. So method for determining rank. So here we have the calorific value, volatile matter and the fixed carbon. And the calorific values are used to define the coal rank in low and medium rank coals below the rank of medium volatile bituminous in the US classification system. So here we can see that this is the medium volatile bituminous coal. So below this, the calorific values are utilized to define the low rank and the medium rank coal. But after this, mainly the volatile matter and the fixed carbon in terms of percentage, they are utilized for ranking the coal. In India, the grading of coal is done on the basis of whether the coal is non-coking or coking coal. So, non-coking coal is the one which is having the higher ash content and are mainly utilized in the thermal power plant as the steam coal. So, in this case, in the non-coking coal, mainly the gross calorific value is utilized, and this is defined as the amount of heat which is evolved when a unit weight of coal is entirely burned, and it indicates the useful energy content of coal. So more the gross calorific value, it indicates that less coal is needed to produce 1 unit of electricity, and it provides the estimation of the plant's production cost. And the second category is coking coal. So this is a type of coal which on heating in the absence of air, it undergoes a transformation. This transformation is in the form that it melt, vesiculate and harden into a sponge-like mass of almost pure carbon. So for this coking coal, the grading is done on the basis of the ash content and the moisture content. So we can see the grading of non-coking and coking coal at this particular website. So here we can see the gradation of the non-coking coal is based on the gross calorific value, while the gradation of the coking coal is based on the ash content, and if it is the coking or weakly coking coal, it is based on the ash plus moisture content. So here we can see that for coking coal, on the basis of the ash content, if it is less than 15% or 15 to 18%, we have the category in the steel grade. But after that, we have the washery grade. And here we can see that the ash content, it eases. So washery grade is simply where the coal is first washed to remove all the impurities before utilization. So here we have different grades within the washery grade on the basis of the variance in the ash content. And then for semi-coking and the weakly coking coal, we have the ash plus moisture. And on this basis, we have two grades. And for the non-coking coal, here we have the gross calorific value and the range is given. So if it is more than 7,000 kilocalorie per kg, so it is grade 1. And after this, we are having different ranges. So accordingly, there are total 17 grades for the non-coking coal. This is a schematic representation of conversion of coal into coke. So coal is collected from the site and it is processed, and different preparation is done, and it is subjected to the coking. So coking is the process of heating the coal in the absence of oxygen at temperature above 600 Celsius, so that all the volatile materials are removed and we get hard, strong, porous material which is having the high carbon content, and it is referred as the coke. So from here, this coke which is obtained, it is cooled or quenched. Quenching is simply the heat treatment process which involves the rapidly cooling of the heated material so that it can achieve the specific property. So from here, the coke is graded and screened out, and it is shipped to different industries, and the gas which is released in the coking process is subjected for the removal of tar, ammonia, hydrosulfide and the benzol, and this cleaned coke oven gas is supplied to the coke chamber heating or the energy production combustion, and the wastewater which is released in this process, it is further subjected to the hazardous treatment. So the coke which is formed here, it is utilized as a fuel and as a reducing agent in the smelting iron ore in a blast furnace, and this coke is grey, hard and is porous in nature, and it is having the heating value of 24.8 billion BTU per ton. Another application of coal is in thermal power plants. So here coal, it is burned to generate the electricity. We can see in this diagram that this coal, it is crushed and is converted into the powder like form to be utilized as the fuel in the boiler, and we have a pipeline which carry the liquid water, and as it is subjected to this boiler, it is converted into the steam. This steam, it rotates the turbine, and this turbine is connected to the generator which generates the electricity, and through the help of the transformer, it is distributed to the power lines and to the consumers. And here we have another loop of pipe which carries the cold water from the cooling water storage to convert this steam back to the liquid water. So this is the circulation loop of the cooling water, and here we have the movement of the steam, and this is converted into the liquid water which is again subjected to the boiler for conversion into the steam. So when we burn the coal, there is possibility that lot of air pollutants will be generated. So the emission which is generated in this boiler, it is subjected to different air pollution treatment technique before it is released into the atmosphere. So here we have the emission monitor which continuously monitor the concentration of air pollutant before this emission is released into the atmosphere. We can also utilize coal by converting them into the gases and the liquid fuels. So this solid coal can be converted into the synthetic natural gas by the process coal gasification, which removes the sulfur and other impurities, and then it can be converted into the liquid fuels such as the methanol or the synthetic gasoline, and the process is referred as the coal liquefaction. And these fuels which are generated from the coal are referred as the syn fuel, which is the abbreviation of the synthetic fuels, and these are referred as the cleaner version of the coal. But in comparison to burning the coal directly, the production of syn fuel, it requires mining 50% more coal, but it can be of importance in those places where we have the abundance of coal but very limited reserve of the crude oil or the natural gas. So here it is the schematic representation of the coal gasification process. Crushed and water in the form of slurry along with the oxygen, it is subjected to the gasifier, and then in this gasifier syngas is generated. Syngas is a mixture of hydrogen and the carbon monoxide. So when it is subjected to the heat exchanger, we can generate the high pressure steam which can be utilized to rotate the turbine for generation of electricity, and then this syngas can also be utilized for generation of the hydrogen which can be used in the fuel pump or the fuel cell electricity. The syngas is also utilized in the formation of different liquid fuels. So that can be distributed to different industries for generation of different chemicals. In the cleaning process, we also have the recovery of liquid sulfur, which can be supplied to the industry where sulfuric acid is formed. This clean syngas can be directly burned in the gas turbine to generate the electricity, or it can be utilized for generation of the hot steam, and it can be used in the steam turbine for generation of electricity. So we can see that through the generation of syngas, we are having the formation of hydrogen, formation of different liquid fuel. We also get the liquid sulfur, and then we are having the generation of electricity. So this coal gasification, it is not only giving us the synthetic gas, but this synthetic gas is the precursor of different chemicals as well as the hydrogen fuel. Now coming to the coal liquefaction, it is the process where coal is converted into the liquid hydrocarbon like the liquid fuels or the petrochemicals. So this liquefaction can be done in two ways, direct or the indirect liquefaction. So in the direct liquefaction, coal and hydrogen, it is subjected to high temperature and pressure to produce this liquid. In indirect liquefaction, it involves the gasification of the coal to synthetic gas, which is the mixture of hydrogen and carbon monoxide. And then this synthetic gas is utilized for the subsequent production of the liquid through the introduction of the catalyst. So both the ways can be utilized for the conversion of the coal to the liquid hydrocarbon. These are also referred as coal to liquid, because this liquid, it is not extracted from the nature, but it is converted from the coal. So this is the process where the coal is converted into the liquid fuels like the diesel or the gasoline. And it is mainly used in the countries with the abundant coal sources but are lacking the oil reserves like the China and the South Africa, and it will reduce the dependence on the oil import and enhance a country energy security. These are the two references which I would like to mention here, as well as I will put in the description box. Uh, all the images have been taken from the Google, and this particular PDF, it contains the summary of the non-renewable energy resources, their formation, and the second website, it contains the case studies of the places where coal is converted into the liquid fuel or the coal gasification is done. Thank you for your continuous support. We will meet soon in the next video with the concept of the crude oil and the natural gas. Thank you.